Hi students, Santosh here, and after a long gap I am continuing my lectures on concrete technology. This is the lecture number 5 part 1 and which deals with the concrete. So let us start the lecture without wasting any time. First of all, what is the definition of concrete? The cement concrete is a mixture of coarse aggregate, fine aggregate, cement and water in certain proportion so as to make a mass of desired quality. I am stating that instead of concrete, I am saying that it is a mass. So, this is the definition of concrete. Concrete म्हणजे काय आहे? तर ते असं मिश्रण आहे की ज्याच्यात खडी आहे, ज्याच्यात वाळू आहे, ज्याच्यात सिमेंट आहे आणि ज्याच्यात वॉटर आहे. आणि हे सगळं मिक्सचर किंवा हे सगळं मिश्रण एक असं मास बनवतं किंवा अशी वस्तू बनवतं की त्याच्यात डिझायर्ड क्वालिटी आणि क्वांटिटी आहे. थोडक्यात समटाइम्स स्पेशल इन्ग्रेडियंट्स नोन ॲज ॲडमिक्चर्स आर ऑल्सो ॲडेड टू दीज सो ॲज टू इन्क्लूड ऑर इम्प्रूव्ह सम प्रॉपर्टी इन कॉन्क्रीट. कॉन्क्रीटमध्ये काही क्वालिटी ॲड किंवा काही क्वालिटी इम्प्रूव्ह करायचे असतील तर ॲडमिक्चर ॲड करतात आणि असे ॲडमिक्चर्ससुद्धा पार्ट ऑफ कॉन्क्रीट असतात. Fresh concrete, the fresh mixture of coarse aggregate, fine aggregate, cement and water in suitable proportion is termed as a fresh concrete. Then what is the hardened concrete? As the time passes, above mentioned mixtures get hardened. This hardened mixture is termed as a hardened concrete. Fresh concrete म्हणजे जे फ्रेश आहे, hardened म्हणजे आफ्टर सर्टन पॅसेज ऑफ टाईम जे कॉन्क्रीट घट्ट बनतं अशा कॉन्क्रीटला hardened concrete म्हणतात. The characteristic strength is defined as the strength of material below which not more than 5% of test results are expected to fall. म्हणजेच अशी स्ट्रेंथ आहे की ज्याच्यात 5% जे सॅम्पल्स आपण टेस्ट करतो आहे ते त्यात स्ट्रेंथच्या खाली फेल नाही झाले पाहिजे. म्हणजे M15 असेल आणि स्ट्रेंथ 15 मेगापास्कल असेल तर एकूण 100 सॅम्पल टेस्ट केले तर 5%पेक्षा जास्त सॅम्पलची स्ट्रेंथ 15 MPaपेक्षा कमी नाही आली पाहिजे. अशा स्ट्रेंथला कॅरेक्टरिस्टिक स्ट्रेंथ असं म्हणतात. हे नक्की लक्षात ठेवा. देन नेसेसिटी ऑफ सुपरविजन फॉर कॉन्क्रीटिंग ऑपरेशन टू क्युअर द कॉन्क्रीट प्रॉपरली. देन टू मेंटेन द वॉटर सिमेंट रेशो फॉर करेक्ट स्ट्रेंथ. टू मिक्स द इन्ग्रेडियंट्स इन प्रॉपर प्रपोर्शन. टू सी द कॉन्क्रीट डज नॉट सेट बिफोर प्लेसिंग इट इन द फॉर्मवर्क. टू अवॉइड द सॅग्रिगेशन अँड ब्लीडिंग. टू मेक अ कॉन्क्रीट ॲज अ गुड फिनिश्ड प्रोडक्ट. Supervision is necessary to complete all concreting operations in a standard manner. It is necessary to avoid any type of delay in concrete work. म्हणजेच कॉन्क्रीटचं सुपरविजन कशाला पाहिजे तर इन्ग्रेडियंट्स व्यवस्थित मिक्स केलेत का नाहीत, वॉटर सिमेंट रेशो व्यवस्थित आहे का नाही, सॅग्रिगेशन अँड ब्लीडिंग कॉन्क्रीटचं अवॉइड करण्यासाठी, कॉन्क्रीटला एक स्टँडर्ड प्रोडक्ट बनवण्यासाठी. त्यामुळं कॉन्क्रीटचं सुपरविजन हे अत्यंत महत्त्वाचं आहे आणि त्याच्यात टाईम डिले नाही झाला पाहिजे. देन ग्रेड्स ऑफ कॉन्क्रीट. कॉन्क्रीट इज जनरली ग्रेडेड अकॉर्डिंग टू इट्स कॉम्प्रेसिव्ह स्ट्रेंथ. द व्हेरियस ग्रेड्स ऑफ कॉन्क्रीट्स आर स्टिप्युलेटेड इन IS 456-2000. दिस इज द नेम or code of concrete. The concrete grade lower than M20 are not suitable for the RCC works and grades of concrete lower than M35 are not to be used for pre-stressed concrete works. म्हणजेच M20पेक्षा खालच्या ग्रेड या रिन्फोर्स कॉन्क्रीटला नाही वापरल्या पाहिजेत आणि M35च्या वरच्या ग्रेड सगळ्या प्रिस्ट्रेस कॉन्क्रीटसाठी वापरल्या पाहिजेत. देन वी आर गोइंग टू डिफाईन द ऑर्डिनरी कॉन्क्रीट. ऑर्डिनरी कॉन्क्रीट mixes or nominal concrete mixes are classified as per IS 456-2000 as a M10, M15, M20 having minimum compressive strength after 28 days are 10 Newton per mm square, 15 Newton per mm square and 20 Newton per mm square means 20 megapascal respectively. Then standard concrete. Standard concrete mixes are classified as per IS 456-2000 as a M25, M30, M35, M40, M45, M50 and M55 having minimum compressive strength after 28 days as a that number indicates the compressive strength in MP or Newton per mm square. It is so simple. Then high strength concrete. These grades are classified as M60, M65, M70, M75, M80 specially used for pre-stressed concrete giving minimum strength as a 60, 65, 70, 75 and 80 megapascal respectively. Then this is table 3.1, shows the grades of concrete as per IS 456 2000, that M10 having 10, M10 proportion 136, M15 proportion as per volume or weight is 1 to 4, and M20 is 1/2 is to 3. These are the proportions as per volume, not as per weight. Then standard concrete M25. M25 is 1 is to 1 is to 2, means 1 part of cement, 1 part of coarse aggregate and 2 parts of fine aggregate, and the strengths are the number, and that number expressed in Newton per mm square. It is so simple. Then we are going to discuss the process diagram of concrete. First of all, we have to procure the material. That procurement of material is the first step. Second is the batching of concrete, means weigh batching or volume batching. Then mixing of concrete. After mixing, then we have to make the formwork for the concrete. Then we have to transport that material and that place that concrete. After placing the concrete, we have to do the compaction. After compaction, we have to finish the concrete, and after finishing the concrete, we have to cure the concrete. And this is the flow diagram, or we can say as a process diagram of concrete. One must remember all these processes. This is the concrete chain. The concrete chain consisting of the following operations in series. First is the procurement of ingredients of concrete. म्हणजेच काय, सिमेंट, सँड, कोर्स ॲग्रिगेट हे विकत घ्यायचे. देन स्टोरेज अँड हँडलिंग ऑफ इन्ग्रेडियंट्स सो दॅट वेस्टेज डज नॉट टेक्स प्लेस, म्हणजेच या मटेरियलचं स्टोरेज आणि हँडलिंग व्यवस्थित करायचं. देन बॅचिंग, द मेजरमेंट ऑफ मटेरियल फॉर मेकिंग कॉन्क्रीट. बॅचिंग हे वे बॅचिंग असू शकतं किंवा व्हॅल्यूम बॅचिंग असू शकतं. मिक्सिंग द इन्ग्रेडियंट्स इन प्रॉपर प्रपोर्शन, ते इन्ग्रेडियंट्स मिक्स करायचे. देन ट्रान्सपोर्टिंग द मिक्स्ड इन्ग्रेडियंट, that fresh concrete to the site, then placing the fresh concrete in molds, compacting the concrete, curing of concrete, and testing of concrete in plastic and hardened state, or we may call it as a stage. Then this is very important question, water cement ratio. The ratio of weight of water to the weight of cement in concrete mix is called as a water cement ratio. It is usually expressed in liter of water required per bag of cement. The strength of concrete is controlled by the quality and quantity of ingredients. Excess quantity of water creates segregation and bleeding, whereas insufficient quantity of water makes the concrete harsh and unworkable. So we have to place the requisite quantity of water in concrete. Water is used for making concrete for 3 different purposes: for mixing, for curing, and for washing. Then we are going to discuss the Duff Abrahams water cement law. It is so simple. Duff Abraham says that the strength of the concrete is depend upon the water cement ratio, means weight of water divided by weight of cement. Water cement ratio affects the strength of concrete maximum, whereas other factors such as grading, texture, shape, stiffness, size, etc. indirectly affect the strength of concrete by affecting the water cement ratio. The strength of concrete primarily depend upon the strength of cement paste. The strength of the cement generally depend upon the quantity of cement. If the quantity is less, strength is less. In 1918, Duff Abraham presented his classic law in the form that S strength is equal to A divided by B raised to X, where X is equal to water cement ratio and A and B are the constants. That is the Duff Abraham. But in simple, the strength of the concrete is depend upon, or it directly depend upon the water cement ratio, means weight of water divided by weight of cement. Abraham's water cement ratio law states that the strength of the concrete is only depending upon the water cement ratio, provided the mix is workable. The mix workable पाहिजे. The relationship between the water cement ratio and strength of the concrete is shown in the figure. What is the figure? On y-axis there is a compressive strength, and on x-axis there is a water cement ratio. This is the graph. When water cement ratio increases, the compressive strength decreases. Then if we want to make the compressive strength higher, we have to make the water cement ratio lower. But one must remember that the mix should not be unworkable or harsh. And this is enough for this lecture. So thanking you, and I am now going to deliver the series of concrete technology lectures step by step or day to day to give you sufficient idea about concrete technology. So thanking you, and please subscribe my channel if you are interested in MPSC or other civil engineering type of examination. Thanking you. Bye bye. See you.